Hi, back to the Sound City 120 PA, 120 watt 6 channel PA, and we've done all the capacitors now. Use mainly F&T capacitors, and we've also replaced one or two resistors. Replaced this voltage drop-in resistor, and we've replaced the balance resistors, the bleed resistors across the filter caps. Also replaced the 4 cathode bias caps in the preamp. Replaced this one, but this is temporary. I'm waiting for the correct part to come. So we've got the 6 Mullard EL34s in. It is switched on. This is insulated, I'm taking great care. And all 6 channels are the same. But we've got another fault on it. Replacing these capacitors and all the work done so far has cured the main problems. But we've got an interesting fault which I thought I'd share with you. So let's plug a signal into channel 1 first, and you can see a nice clean output. Channel 2, nice. 3, nice. 4, shocking, terrible. That will sound awful. That's channel 4. Channel 5's good. Channel 6 good. We'll put it back into the bad channel, and when that's cranked, amplified even more, it's shocking. There's no schematic online for this model, or at least I couldn't find one, so I've sketched it out, and this is a simplified diagram. And so that's channel 1, 2, 3, 4, 5, 6, and these are, if you like, these are the input jacks, and this is just done in a block diagram to simplify things. So treble, bass, volume, stage, and the preamp valve. So with 3 valves, with V1A, V1B, 2A, 2B, 3A, 3B. With 3 valves, but of course each valve's a double triode. So if I scoped, let's see, the bad channel's this one. If I put the oscilloscope on here, it was absolutely fine. I could compare it to a good channel, and it was absolutely fine. So out of the 6 preamps, it goes into what's called a buffer stage for further amplification and for mixing. So you're combining, so if you want to plug 2 or 3 instruments or microphones, whatever, into the channels, you can set the levels and you combine it with this bit. So you have another 6 triodes done by 3 valves, double triodes, and the output is summed up, the sum of all the 6 channels, if you like, summed up, and then it comes out of here and goes to the effects loop and onto the master volume. So if I scoped on the bad channel just here, it was terrible, but it was good here. So the problem was in this stage. Now this has been very simply drawn, but this is the full circuit, and all we've got is 5 components in the valve. So that's all it could be. But all these components actually tested fine, 100%. So if we put it to standby and take out, I believe it was this one, yeah, this valve, and it's a Mullard but it's the later logo one from the, let's have a look, I63B4H1. So that's a 1974 tube. We'll put it in the Avo and let's take a look. It's all set up for ECC 83s. On this scale, take no notice of the replace good, we're not using that. We're looking at this 0 to 2.5. And for an ECC 83 it should measure 1.2-ish, or anything between 1 and 1.5. So it's warmed up now, it's all set. Let's put it to test. And it's gone right over to 2.5 milliamps. So that's wrong. It's drawing more current than it should be doing. Let's test the other section. We'll put it onto anode 1, and wow, that is drawing excessive current. It's actually drawing 11 milliamps. So that's just not on. Drawing too much current. So let's let's find a good valve. Nice yellow print mullard. Nice flash as we plug it in. Let it warm a little bit. And let's take a look now. Oh, that looks much better. And there we have it. Slightly overdriving it, so let's knock the gain down a little bit. That's much better. Just check all the other channels. Yeah, they're not all set at the same levels, but I can see now that that's fully repaired. So there we have it. Hope that's been of interest to you, and thanks for watching.